Welcome to page 3 with a new background color. Ooh. So sorry I don't have your equation box here like I did on the math practice, but I went ahead and wrote the equations up above. These equations will be provided for you on the test, not this one. This is a conceptual idea, but these two equations will be provided for you on the test. So when we enter in this box situation, we want to try and solve what we know. So when we see this blank for the h, we can't necessarily start here because to solve for h, we would need EG, and we just don't have anything in this column. Now we do have velocity. What can velocity tell us? Whenever we see a v, we know that we can solve for the kinetic energy, right? 1/2 mv squared. When v is 0, of course, this whole thing is 0. And again, I don't have to put j because j is up here. Otherwise, you would have to put the units, but because the units are in the top column, so you don't have to put them. So, 0 kinetic energy because we've got velocity. We know that. But I can't see anything else in this row that we can solve. And same for these, or I can move down the EK, right? Each time I can solve for the EK. So, I plug in my equation, right? 1/2. My m is, from the question, it's almost always in the question, 4 times, what is my v? 10 squared. So 2 times 100. So 200, and then 15 squared is, what, I think like 225 times 2 would be 450. Again, this is something you should have done already. I'm not going to do everything. And then 20 squared is 400 times 2 is 800. So I went down the column of what I knew. I had velocity, so I knew that. So then I realized, okay, maybe when I get down to here, I realize, well, I do have a 1 height here. And so I can solve for the MGH at height 0, which is, of course, 0. Right? No more gravitational potential energy once the thing has reached the ground. So 0, 0, and 800. Okay, now maybe I've got a little bit more information. We got to keep trying to piece this together. Walk yourself around the chart. Do I have the total energy now? EG plus EK? Yes, 800. And so 800 joules of kinetic energy at the bottom means 800 joules of total energy. And so this must be the total energy for the entire situation. We've talked about this every single day. The total energy during a process never changes. So I can just go up the line and I can put 800 in for all of these. Now I can loop back and solve for my EG. Not using MGH, right? MGH doesn't have, I don't have an H. So I have no way to solve this. But I do have an EG somewhere else. You got to go looking. Where else do I see EG? Oh, right there. EG plus EK is my total. So maybe I can solve for that. If I have my total, 800, and I've got my K of 0, how much EG must I have? 800. And here, the difference between these two, 600, and then 350. So my EG is dropping as my EK goes up. And we saw this on the math practice. So, moving forward now, I can find the H's. I've got the EG. Again, this is super critical that we try to think, what do I know, and then what can I solve? So this is why we want to write the whole equation whenever we do the math. EG equals MGH. So when I plug it in, I actually don't have MGH to solve for EG. I've got EG. 800 equals, what's my mass? 4. What's G? G is always 10. And that will be on the test as well. G equals 10 meters per second squared. And then my H is what I'm looking for. So then, algebra, we divide both sides by 40, because 4 times 10 is 40. And so, of course, the answer is 20. I wanted to make sure I got it right. So 20 is the answer here, is my height. And we just keep doing that. 600 divided by 40, right? All of this is the same. The 4 and the 10 are the same. The only thing that changes is this. So 600 divided by 40, 15. 350 divided by 40, 8.75. and then 0. And I gotta say, it's a pretty big coincidence that this is 20 and 15, this is 20 and 15. Do not rely on that. That is definitely a coincidence. All right, so one last thing. I've got these dots out to the side. It says draw appropriately sized velocity vectors on each dot. I could have done that first because my velocity was already filled in. No velocity, right? And then some velocity. And then this one should be twice as big as this one, right? The 20 should be twice as big as the 10, and 15 should be somewhere in between. So I've got bigger and biggest. Different sizes. The size definitely matters. All right, my low-tech solution to my typo here. Peel that out of the way and move upward to get this. So now I want to graph the EG, EK, and ET all versus height. And I can do that because I have this whole column. And it says in 3 different colors is best. I will provide some colored pencils on the test. So, circle each type of energy on the axis label with your chosen color. So, H, what are my different H's? 2015, 8.750. So to set up a graph, right, I write 20 out here, divided by 10. Each one of these must be 2. And then my total energies max out at 800. So I'll put 800 up here. Divided by 10 is 80. All I did was take my maximum and spread it out super fast. Okay, I might have paused the video. So once we've got this plotted, it's just a simple matter of plotting H versus each of the 3 things. So I'm going to do it in the correct colors. For blue, I'm going to do EG, right, because I did it in blue up here. So at height of 20, my EG was 800, and then so on. I'm going to plot all of these in blue. In red, I will plot the EKs. At 0, right, 0 EK is at a height of 20. So my dot is actually way down here. And let's do one other one. At a height of 8.75, my kinetic energy is 450. So somewhere right in there. And I'm going to plot the rest of these as well. And then my total energy, 800 the whole way across. So I get this pattern where as the height goes up, my kinetic energy is going down. As the height goes up, the gravitational potential energy is going up, and the total energy is staying exactly the same. All 3 patterns exist on this same chart. All right, so for number 12, it says in the kinetic energy lab, we found that the height we dropped the ball from increased the velocity it had at the floor, right? We had different heights, we had different velocities, and when we graphed them, we saw the higher we dropped from, the more velocity it had. But the relationship between height and EK is inverse here. As the height goes up, the kinetic energy is going down. And really, what's happening is as the kinetic energy goes up, it's happening because the height is dropping, right? We're at a high height here, and we're lowering our height, and the kinetic energy is rising. So, basically, in the lab, we dropped from different heights, and we found the velocity at the floor. In this case, the height is dropping, and we're studying just one drop. So before we studied different drops and the velocity at the bottom. Now we're looking at the velocity as it falls in a single drop. And as an object falls, it speeds up. Lowers height, right? Gets closer to the ground. And speeds up. All right, so now for these math problems. Our procedure is always the same. We've got to pick out any of our variables and label them. It's so important. 6,000 kilograms must be a mass. 30 meters per second must be a velocity. What equation uses mass and velocity? Look back on our patterns page. We use the test to take the test. Look back on our patterns page. Which one of my equations has mass? Oh, there it is, mass and velocity. Right? So 6-kilogram van traveling 30 meters per second, mass and velocity. I always want you to write the whole equation. EK equals 1/2 mv squared. If you write this, that's sum of the points. Then the next step is simply to plug them in. Equals 1/2 specific m times specific v squared. And we have to make sure when we're using our calculator that we do 30 squared, right, times 6,000 times 0.5. We do not want to go in the other order. Trouble that way lies. So we get a pretty big number here, 27 and 1, 2, 3, 4, 5 zeros. And we got to have our J. It's so important to have joules. And when we're squaring 30, when a big car van is going fast, it's going to have a pretty big kinetic energy. All right, so then this one, my other car. 1,000 kilograms is a mass. 15-meter high hill. Parked means no velocity. 15-meter high must be an h. What equation? We go look at our equations on our patterns page, and we pick out, okay, not mv, right? mgh. So we write the whole equation. EGP equals mgh. And then we can plug it in. So m is 1,000. Our g is always 10. And then our h, in this case, is 15. So this is just 1, 5, and then 4 zeros. 1, 5. Multiplying by 10 or 1,000 is just a matter of adding zeros. And I got to have that J. Got to have that joules. All right, so then this one, you start it the same way. We think, okay, what is this? 3,000 kilograms must be a mass, right? 4 meters per second must be a V, and 12 meters must be an H. And a lot of students ask me, okay, well, what equation has all three of these? And you're right, none of the equations have all three of these. But there's two different energies. This is like a catapult from medieval times. It fires up into the air and it has so much energy because it has both kinetic, where it's moving sideways, and the potential to drop back down. Catastrophic injuries, right? So we're going to use both equations. Let's do this one first. It doesn't really matter the order. EK equals 1/2 mv squared. And we're going to plug in our two things. 1/2 times 3,000 times 4 squared. I'm sorry, it's got a little cramped in here, but 4 squared is 16. Handy Danny's trusty calculator. I'm going to square the 4 first, right? 4 squared, and hit enter. And then times 3,000 divided by 2, which is the same as times 0.5, right? So my total answer here is 24,000, but I'm not done yet because this is also on a hill. So I'm also going to EG equals mgh and plug in those. What's my mass? 3,000 times 10, and then my height is 12. So 12 times 3 is 36, and then 4 zeros. So this equals 36,000 joules. I didn't put a J here, that's my mistake. Now to get the total answer, I need to add these up, right? I'm not done until I add these up. So 36 plus 24, I'm just going to put in 1, 2, 3, 24, right? I'm just going to put it underneath. You can also do this on your calculator. So my final answer is 0.00483, 384,000. So going back up to the original question, it said circle the one with the greatest total. So which one of these has the most total energy? 384,000, 150,000. If I check my commas here, this one's actually 2.7 million, 2,700,000. And that's because the van is huge, right? And it's going very fast. This one is not going as fast. Even though it has two energies, it's not going as fast. So A has the greatest total energy. All right, so 14 is this idea, we have to just kind of go with what we've got. If we just start things off, 1 kilogram must be a mass, 40 meters per second has got to be a velocity, and we just go with what we've got. What's our equation that involves mass and velocity? EK equals 1/2 mv squared. We plug in our formulas. 1/2 times, what's my m? 1, times v squared, what's my v? 40 squared. So this is 1/2 of 1600, and so this is actually 800 joules. And some people think they're done here because they've solved for the kinetic energy. This is why I always want us to be checking, what did the question ask for? This one asked for the energy, and when we got energy, we were done. But this one asked for the height. And so the crucial idea here is that E before equals E after. If I throw something up with the kinetic energy is going to turn into E before equals E after. So if I plug in EK, it's going to equal EG by the end. So this number is now my EG at the top of the arc as it gets to the top. So now I've got EG equals mgh. I go grab my EG formula. We only have 2 formulas. You're going to have to keep grabbing them. Grab the formula that you need. This time we need the EG equals mgh. And then the reason we write the whole formula with the equal sign is so that this time we have to plug in the EG. It's 800. Equals, and I'm going to keep plugging things in, mass of 1, so that's easy. G is 10, and my height is what I'm looking for. I keep that as a variable. So to solve for this, divide both sides by 10, and I have h equals 80 meters. So that's your review. Check this out, check things back, do your best, come in Thursday or Friday, ready to get it done.